For this last exercise of the chapter, let's create a number guessing game and do that using a do-while loop to demonstrate again how programs with user prompts work better with do-while loops. So we need to start out by pound including the libraries we need to generate random numbers because we want to generate a random number as our number to guess. So we pound include cstdlib and ctime. And that's all we need to do. We'll begin the program. First thing let's do is let's go ahead and seed the random number generator. So we call the srand function with null time. Then let's create a couple of integer variables for the number we're going to have to guess and for the guess that we get from the user. Let's go ahead and generate the random number at this point. So we'll generate a number in the range of 1 to 10. So we write rand mod 10 plus 1 and assign that to number. We need a char variable to store when the user is prompted whether they want to continue guessing or not. That's how the game is going to be played. We're going to prompt the user to enter a guess. They'll make their guess. We'll either tell them they're right or they're wrong and do you want to continue. So our char variable cont will be the variable that stores that answer from the user. At this point we're ready to jump into the loop, so we write do and open the do statement with the opening curly brace. Now we prompt the user, guess a number, and we get that guess from the console. Right off the bat, we write if guess is equal to number, cout, that's right, and we're actually finished with the program. However, we're in a do loop and we need to get out of it at this point, so we're going to use a special keyword that prematurely exits you from a loop, and that keyword is break. Break always applies to a while loop or a do-while loop and will take you to the first statement after the loop. Some programming experts consider premature exits to not be good programming style. Several years ago that was probably true, but now it's fairly common for a situation like this to use a break to get out of a loop. So we'll use it in this particular program. And that's all we have to do if the user guesses the number correctly. Then if they don't guess the number correctly, we'll prompt them, sorry, do you want to guess again? And then we'll get their answer stored in cont, and that's the end of the loop. So we're going to write while cont is not equal to no. And that's the whole program. So let's build and run and see how it works. So we'll guess the number, we'll guess 5. Sorry, do you want to guess again? Yes. Guess the number, we'll guess 1. Sorry, do you want to guess again? Yes. We'll guess 10. Yes. No, whatever. 6. Yes, we want to keep guessing. Let's go high. 9. That's right. This was a short program, but again, it clearly demonstrates that the do-while loop works best in a loop like this where you need to prompt the user because you always want to execute the body of the loop one time. If the user guesses on the first guess, then the program exits after the very first time in. But you still want to execute the loop once, at least once. If they guess wrong, then we just continue looping until they either get tired of playing. In fact, let's run it one more time just to verify that that works. So we'll guess 5, we'll guess 3. Oops, I put 3, but the same thing as yes. We'll put 3, yes, we'll put 7, and then we're going to write no, and that takes us out. So that verifies that that works. So the do-while loop is used when you always want to enter the body of the loop at least one time. For most numeric calculation type programs, like trying to compute a balance or something like that, it really doesn't matter, and a while loop works just as well. But for these type of user prompted loops, I'll say it one more time, the do-while loop is usually the best solution. That wraps up our chapter on additional control flow constructs. For the next chapter, we're going to move into text processing with text files and random access files.